Today's video on how our solar system formed, also known as the nebular hypothesis. The leading idea is the nebular hypothesis. The sun and planets formed from a collapsing cloud about 4.6 billion years ago. When gravity beat internal pressure, the cloud spun fast and flattened. That creates a rotating disk because of angular momentum. So the conservation of angular momentum led to a spinning disk which then, of course, resulted into a flattened disk. And hence, the solar system is essentially a disk. In the hot center, the proto-sun, proto just means the early sun, first few years of the sun, ignited when fusion started. Around it, dust pebbles stuck together into bodies by accretion. So the accretion, which really is the process of dust becoming pebbles, becoming planetesimals, becoming protoplanets, and eventually becoming planets. I'll show you a short simulation about this later. Now, why do scientists trust this model? Well, the answer is always evidence, not the name. Here are the cleanest, most visual pieces. We directly see baby solar systems, actual disks. Telescopes image protoplanetary disks around newborn stars in star-forming regions. So these are called proplyds, which are protoplanetary disks around young stars. So we can actually observe other systems and learn about the creation of our own. Second piece of evidence is rings and gaps in some disks mean planets are forming. Young planets carve paths as they grow, leaving bright rings and dark gaps. So these rings and gaps lead to planets clearing material. Third piece of evidence is that our planets move on in one plane and in the same direction. That orderly motion is exactly what a flat rotating birth disk predicts. So the orderly motion, the fact that all the planets are in the same direction and on a nearly ecliptic plane, is the third piece of evidence. The fourth piece of evidence is that inner versus outer worlds match temperature physics. Inside the frost line, only rock and metal condense. Outside, ice and gas pile up fast. So the inner terrestrial planets are mostly formed of rocks and metal, while the outer planets are formed of ice and gas, lining up with what physics would predict. The fifth line of evidence is that the ages line up with a test start. The oldest solids date back to about 4.567 billion years. Cores formed early in many bodies. So the things we can clock, we can find the age of here on Earth. The oldest things we can find the age of are almost exactly what other pieces of evidence would have predicted the universe started in. The sixth piece of evidence is a nearby stellar event could have nudged collapse. Short-lived radionuclides in meteorites suggest fresh stellar input, plausible supernova, or similar. The seventh piece of evidence is that exoplanet systems echo our story. Many multi-planet systems are coplanar, consistent with formation in disks. So by exoplanets, I mean planets outside of our solar system. And because we can observe planets outside of our solar system and we observe similar things in other parts of the universe, we can expect those things to be true for our solar system. So to decode some of the jargon that I've mentioned so far, accretion is the idea that small pieces collide and stick, building bigger pieces. What drives accretion is really the gravitational forces, the fact that mass is attracted to mass. And planetesimal is kilometer scale building blocks of planets. Differentiation, that just means when heavy stuff sinks and light stuff rises inside young planets. This makes metallic cores, rocky mantles, and lighter crusts, things that we can clearly observe in our own planet. But it's true for other planets in the, especially the terrestrial planets, but also other exoplanets that are similar distances from the sun, from their stars, I should say. Frost line means that when you get far enough from the sun for certain gases to freeze into grains, that boosts solid mass so giant planets can grow quickly. So this frost line explains why the planets Jupiter, Saturn, Uranus, Neptune are so giant. And that snow line or frost line distance depends on the temperature, depends on how massive the star is. Energy note, conservation in action. As gas falls inward, gravitational energy becomes heat and light before fusion. So energy means that the gravitational potential energy leads to heat and light, and thus energy is conserved. What would falsify the nebular picture? If newborn stars mostly lacked disks, or if mature systems were wildly non-coplanar, then we would worry. But of course, our observations inside our solar system match the observations we are making outside of our solar system. If meteoric ages showed a slow scattered formation, we'd also worry, but observations show the opposite. If the universe had a TikTok, HL Tau style planet, glow ups will go viral. So I wanted to show a quick simulation of how the solar system formed and what the nebular hypothesis looks like. So let's watch this video. So you can see the protostar in the middle. You can see the planets starting to form. As I mentioned, gravity is what leads to accretion. Let me show you one other thing. So this is a simulation I found online, and it gives you the idea of how the planets formed due to gravitational forces. So remember, gravity is mass attracted to other mass. And you could see how these little particles here all kind of clump together and form the planets. So I hope these two simulations helped everyone visualize the nebular hypothesis. Quick recap. Gravity collapsed a gas dust cloud into a spitting disk. The sun formed in the hot center, while planets grew by accretion. We see disks, rings, gaps, and orderly planetary planes. Frost line physics explains inner rocks versus outer giants. Meteorites collected here on Earth date back to the start of the universe, of the solar system, which was about 4.567 billion years ago. And exoplanet systems often look coplanar, coplanar just meaning on a disk, on a plane, reinforcing the models that we have today. Thank you. I hope to see you in the next video.